Okay, dear students, so in this lecture we will discuss mesh current method. So in the first part of this lecture series, we will introduce how a mesh current method applies to electrical circuits. So let's consider a simple circuit. We have a voltage source. If the resistance for there and another resistance is connected like this, and we have another voltage source. Okay, so let us consider this voltage is V1 and this voltage source has voltage V2, and we have resistance R1, we have resistance R2, and we have resistance R3 ohm. And the current flowing in this resistance R1 is I1, and current flowing through this resistance R2 is I2, and the current flowing through resistance R3 is I3. So we have now three currents, or you can say the current flowing in R1 is I1, and the current flowing in R2 is I2, and the current flowing in R3 is I3. And we want to compute these currents I1, I2, and I3. So if we don't know the mesh current methods, we only know the KCL and KVL, how we will proceed. So we have this node, so let's apply KCL in this node. So we will have I1 is equal to I2 and I3. So this is KCL at node, let's say this node is A, node A. So at node A. So we applied KCL at node A, and the sum of the currents flowing in is equal to the sum of the currents flowing out. So we have the current 1 is flowing in to this node, and current I2 and I3, they are flowing out. So I1 is equal to I2 plus I3. Okay, next is we have to use KVL to these two loops. So we have two loops, so we have to use two KVL equations. So applying KVL in this loop, let's say this is loop number 1. Let me write this is L1, and let's say this is loop number 2, L2. So when you apply KVL to loop 1, so we can write this as you see the voltage rise should be equal to the voltage drop. So we have, if we just using this direction, so we have voltage rise and we have voltage drop, I1 R1 and I3 R3. And look at loop 2, L2. So you can see, if you just assume this direction of the current, so the voltage drop here, and when the current is flowing like this, voltage will be dropped, and this V2 will be considered as voltage drop, and here we have voltage drop over here. So we can write the KVL equation like this: minus V2, this is voltage drop, so it can be represented as negative, and I2 R2 plus sorry, with negative sign, I3 R3, because voltage drop, and here this is opposite of this current, so that's why it is represented by negative sign. Now, if you just assume that this is equation number 1, and this is equation number 2, and this is equation number 3. Just after a little bit rearrangement of these two equations, so writing I3 in terms of I1 and I2, and substituting this I3 in equation number 2 and equation number 3. So we can rewrite the expression V2 and V3, equation number 2 and 3 as like this. So V1, and here it is I1 R1, and what is I3? I3 is equal to I1 minus I2. So I1 minus I2. Okay, so it's better to write R3 here just to have the same representation. And similarly, we have V2 is equal to I2 and R2 minus I1 and I2 into R3. Okay, and after further simplification, we have V1 is equal to R1 plus R3, just adding the two resistances R1 and R2 because I1 is there, so we can write this as I1 and minus R3 I2. Okay, and here minus V2 is equal to, now here I2, and this is also I2 R3, so minus into minus plus, so we can write this as R2 plus R3 I2, and here it is minus I1 R3. Okay, so if you just rewrite this expression in terms of that I1 should appear first and I2 should appear second, so you can write this as minus I1 R3 and R2 plus R3 I2. So you see, we have solved the circuit, and we have now two equations and two unknown, so we can easily solve for I1 and I2. So this is how a circuit can be solved using KVL and KCL. But you see the procedure, it is a little bit lengthy, and you have to take care of the nodes, that we apply KCL at this node, and then we apply KVL in two loops, and then finally we ended up with this result after some substitution. So how to use mesh current method? So mesh current method is more systematic way to solve circuits. Okay, so for that we have definitely to take care of the essential nodes, to take care of the essential branches, and based on that we have to proceed. So let's say how to proceed with the mesh current method.